One technique of graphing, when you're not sure what the functions to look like, is just to find ordered pairs. So that's what we're going to do here to find out what is a log of x going to look like on a graph or a picture, and what is natural log of x going to look like. How are they going to be the same, and how are they going to be different? So we'll start with the ordered pair 1. What happens when I plug 1 into this function? Well, the log of 1 is asking what is the exponent on 10 such that I get 1. And that answer is 0. And here, what is the exponent on e such that I get 1? And again, that answer is 0. So both scenarios here have the ordered pair. When I plug in 1, I get out 0. In the second case, what happens when x is larger than 1? Well, 100 is a lot larger than 1. And I chose 100 because 10 to what power is 100? 2. I could have chose 10 just to make it come out nice. 10 to what power is 10? 1. And in this case, natural log of e. E to what power is e? That answer is 1. So we're getting different values now, but we can see that when x is greater than 1, these are positive values. So we'll be plotting those here in just a moment. What happens when x is between 0 and 1? So what happens when it's smaller than 1 but greater than 0? So we chose strategically 1/10. 10 to what power is 1/10? -1, so I can flip that over. And here this would also be -1. E to the -1 is 1 over e. Then what happens when x is less than 0, or in other words, a negative value? So again, we're going to convert this into exponents. 10 to what power is -1? 10 is positive. There's not an exponent that will take a positive 10 and change it to a negative value. So we're going to say that does not exist. And likewise, here we'll try 0, because we said it couldn't be equal to 0. E to what power is 0? What is the exponent on e such that I get 0? E to the first is e. E to the 0 is 1, not 0. So there isn't 1. So we're going to say this does not exist. So it looks like my x's can never be less than or equal to 0. So we'll graph the first log base 10 in blue. Looks like I can plot the point 1, 0. And then we found the value when x is greater than 1, such as when x is 10, I got out 1. We'll plot that because it's a little bit easier. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I got out 1. So it's growing. And then when I was small, such as a 1/10, I got a -1. So the graph then looks like it comes close to here and lays out. It slowly gets larger, but it takes some time for it to grow. We'll graph the natural log. Let's label this as the log of x. We'll graph the natural log in red. Once again, from my first position point here, we have both had 1, 0. And then when when x was equal to e, y was 1. So again, they pass through here. So when x was 2.7 or e, I got up to 1. So this looks to be growing a little bit faster, but still the same layout. This is the natural log of x. Now notice both of these graphs never get beyond the y-axis. They never get in this piece where x is less than or equal to 0. So they follow that line. So we call that line an asymptote. So it's a line on the graph, such as the one above, in which the function approaches but never gets. So I approach this value of 0, but I really never get there. Okay, and that's just a simple definition of an asymptote. You'll study those deeper in pre-calculus.